Welcome to the 7th edition of the TestCon Europe conference. My name is Wim. I'm a learning and development expert at CTG Belgium, and I will be the host for this track today. It is a tremendous pleasure for me to welcome those of you that have been with TestCon Europe for a long time now, as well as those that are new to our community. As every year, the TestCon Europe conference gathers groups of like-minded software assurance practitioners together to learn about the latest testing trends, disclose best practices, and gain inspiration to take their experience to the next level. Yet, this year is exceptional. Our community has grown enormously. We received more than 2,100 registrations from 39 different countries, making us the largest software testing conference in Europe this year. This is a great time for a round of applause. So you can all start hitting that small button with some applause to show your presence here. On today's program, we have 2 inspiring keynote talks, followed by 19 thought-provoking sessions from internationally recognized software testing experts and a panel discussion where different viewpoints will be exchanged about evolution of software quality as a team responsibility. Just in a moment, we're going to dive right into the first session, but before that, I would like to say a special thank you to our sponsors for contributing to this conference. First of all, our platinum sponsor, Keysight Technologies. They work with innovators to push the boundaries of engineering to design, emulate, test, and deliver breakthrough electronics. Our gold sponsor, JetBrains, which is a global software vendor that creates professional software development tools and advanced collaboration solutions trusted by more than 12 million users. Also Upton, which leads the industry in digital platform engineering and product development services. Our bronze sponsors, M47 Labs, Desena, mostly AI. Besides, this year we have 2 knowledge partners who prepared great gifts for you. Pact and Manning companies will award the most active conferencing attendees who rate sessions and leave comments with free ebooks. So don't miss this opportunity. To round off, I would like to encourage everyone to be active, open-minded, and eager to create valuable memories today. So to kick off the first TestCon Europe 22 conference day, I would like to invite our keynote speaker, Steve Upton, who is a lead QA consultant at ThoughtWorks. He's going to talk about the affordance of quality on how to really build in quality. And as you can see, Steve loves colorful shirts, and to contradict with that, he put on a hat because it's rather chilly where he lives. Steve, the stage is all yours.
Thank you for that lovely introduction, Wim, and welcome everyone to TestCon Europe 2022. So, as Wim mentioned, I'm Steve. I'm very easy to find on the internet. I work for ThoughtWorks. We are a global technology consultancy. So if you ever want to work with some really lovely, clever people, come say hi. And this talk is called The Affordances of Quality. And we'll get to that title and what that means in just a sec. But what this talk is about, as Wim said, is building in quality as a concept. What does it mean to build in quality? I searched for this recently and I found almost 2 billion results, which is quite a lot, actually. And full disclosure, I haven't read all of these. They're all on my reading list. I'm working through them, but I just wasn't able to finish them in time. And what interests me, really, is what it really means to build in quality. Out of all of these 2 billion results, what's the thread that ties them together? And that's what I want to try and explore today. But I do have a bit of an admission. This is a little bit of a bait and switch, because while we will be talking about quality a bit, I really want to talk about doors. I love doors, right? I find doors absolutely fascinating. I just think they're super interesting and cool. When I'm walking around town, I sometimes stop and take pictures of doors that I think are interesting or clever. So if you've ever wondered what it's like to be friends with me, it's absolutely terrible. Don't recommend it. And this set of doors on the screen right now, I find really, really interesting. I think these are a fantastic set of doors. And the reason is I want to ask you a question now. Now, unfortunately, I can't see the audience. I can't see your comments, but feel free to put it in the comment or shout at the screen. And if you really believe, maybe I'll hear you. The question is, if you were walking towards these doors, would you push them or would you pull them? Give you a second to think about that. Would you push them or would you pull these doors? As I said, I can't see you, unfortunately, but I have asked this question before to audiences that I can see, and 100% of people always say that they would push these doors, which is interesting because there's no sign on these doors that says push. There's no signal that says you need to push this door, no instruction manual for this door. So how did everyone figure out that you need to push these doors and not pull them? That's an interesting question, isn't it? See, there's elements of the design of these doors that help us understand how we can interact with them. These metal plates here, when you're walking forward, if you hold out your hand, these are about hand length. These are about hand height. They're also shaped roughly the same shape as your hand. You can easily put your hand against them. And they're flat, which makes it easy to push and very hard to pull. It's almost impossible to kind of get a grip on those things and pull them in any way. There's also these plates at the bottom. These are known as kick plates. You can see that they're metal, they're shiny, and they send a signal to you. It's really easy to kick them. So if you're holding something in your hands, it's very easy just to kick these doors open. The doors essentially signal to you that that's fine. You're allowed to do that. And these elements of the design here are what's known as affordances. The term affordances was explored in the book The Design of Everyday Things by Don Norman. It wasn't actually invented here. The history of the term affordances is actually long and surprisingly interesting. But I'll just be kind of focusing on Don Norman's usage of it here. And Don Norman described affordances as, he said, affordances determine what actions are possible. Those elements of the design of the door show you that it's possible to push and not possible to pull. Technically, affordances are a relationship between an agent, a person, you, and the design system. But I actually don't agree with this definition completely. I prefer a slightly broader definition. So imagine you walked into a room and you saw a chair. You look at this chair and you'll see, well, if I bend my legs and kind of sit down, apologies, I'm at a standing desk at the moment, so I can't really do that. Well, I would kind of naturally end up sitting on this lovely sort of soft area here, and that looks very comfortable. You'll see that there's a back here, and that makes it really easy to lean back. It's going to give you some support, and it's going to be really, really comfortable. That's nice. So you're probably going to sit on this chair. We would say that this chair affords sitting. It has affordances for sitting. And if you saw a ball like this one, you would look at this ball and you'll say, well, it's small, it's round, it's kind of bouncy. It fits in my hand, it's light. It's pretty easy to throw this at a wall. It's pretty easy to bounce it around like a little toy and play a game with it. So you're probably going to do that with a ball if you see it. So we would say that this ball affords being thrown. It has affordances for being thrown around the room. But here's the thing. You could walk into a room, look at a chair, and throw it around the room for some reason. You could walk into a room, look at a ball, and decide to sit on it. It would be quite uncomfortable, but you could do that. It's not impossible. The definition of affordances that I prefer is that affordances help us understand what actions are easy. It is easy to throw a ball, so that's what we're likely to do. It's easy to sit on a chair, so that's what we're likely to do with it. And in most cases, given the choice between something hard and something easy, people are going to pick the easy option. Another door here. Another question. Let's say you were walking towards this door. Would you push or would you pull? Again, you can throw your answers in the chat or yell at the screen if you want. But would you push or would you pull? So again, I've asked this question in front of audiences, and usually it's about 50-50 here. About 50% of the people say that they would pull, 50% of the people say they would push. And the answer, unfortunately, is you need to pull this door. So if those of you who said you were going to push, what would have actually happened there is you would have walked into the room, smashed into the door and fallen over, which would have been very embarrassing for you and very funny for the rest of us. But the important thing to understand here is this is not your fault. It's the door's fault. The door has mismatched affordances. You see, if you walk towards it, you hold your hand out, you grab onto that handle there, it's really easy to pull. But it's also really easy to push. There's no obvious action here. It looks like it affords both pushing and pulling, but it actually only allows pulling. And these mismatched affordances lead to lots of, let's say, user experience issues. These doors are actually known as Norman doors, named after Don Norman from The Design of Everyday Things, which, if you kind of think about it, it's actually a really bad thing to be named for. I mean, you know, you develop an entire field of user experience research, and the thing that you get remembered for is the worst possible kind of door. So that's a bit unfortunate. But once you understand affordances, you start seeing them everywhere. There's a pair of scissors with them. So I've got some scissors here. Now, if you notice, if you look at the scissors, there's this kind of long slot here, and there's a smaller slot at the top, right? Long slot, small slot. Now, if you look at your hand, you will notice you've got, most of you, I assume, have 4 fingers, which form kind of a long slot, and you've got 1 thumb, which forms a small slot. And they kind of neatly fit into each other. It's very easy to hold scissors this way. Now, you could do it the other way. You could kind of try to force your fingers in there and get your thumb in there, and that kind of works. Yes, it's possible, but it's a lot easier to do it this way. And that's why you have never seen an instruction manual for a pair of scissors. You just understand how to use them. Again, when you understand the concept of affordances, we see them everywhere. Switches afford flicking. Mugs afford being held in a particular way. They very naturally fit the hand like this. That's why, again, you have never seen instruction manuals for these 2 objects. A huge amount of user experience design, of human-computer interaction, is just understanding and sculpting affordances clearly. But not all affordances are good. So I'm assuming that everyone here is sitting at a desk somewhere. This is a remote conference. Maybe you're sitting at work or at home. I am sat at a desk. And if your desk is anything like mine, it's very messy. I've got a mug here. I've got a ball and some scissors over here. I've got a notepad, a mouse over here, a little box of sweets. Again, terrible, terrible mess, right? I assume your desk looks a bit like this as well. The reason for this is your desk is a flat surface. And flat surfaces afford having things put on them. When you put something down on a flat surface, it stays there. It's very stable. It's very easy to leave it there. I know that I should take this mug out to the kitchen and wash it, but it's easy to put it on the desk. It's easy to let that mess clutter up. This desk affords having stuff put on it, which leads to this sort of flywheel effect of stuff piling up and it getting very messy. So affordances aren't always affording good behaviors. But so far, we've been talking about affordances in designed objects, literally the design of everyday things. But there are affordances in our ways of working as well, in the systems we build around us. I think one really interesting place to look at for affordances is our board. I assume many of you have a board like this. You're maybe working in a development team and you've got a board, right? So you've got a ready for dev column where everything that's ready to be worked on is put. It gets pulled into development. That's where, it's developed. Then there's a QA column where QA and testing is done. And finally, it moves to done. It's ready to go. And maybe your board is a little bit different to this. Maybe you name these things differently. Maybe your column is called test rather than QA. Maybe you include some columns over here about the analysis. Maybe you have some showcase or a stakeholder sign-off column or more analysis columns. There's lots of things that you might have in here, but I assume that this very roughly describes what a lot of you see day to day. Which means an average week probably looks something like this. You've got a few stories ready to go, a few stories done, and you've got a few stories in development. So here we have 2 stories and we have 2 developer pairs working on them. By the way, pairing is a fantastic way of building in quality. You have 2 sets of eyes on every single line of code you write. Fantastic, really, really valuable technique here. And in this particular scenario, I want to focus on this developer pair here. They're working on a story, and they understand the importance of building in quality. So they are thinking about quality. They're thinking about how they can test this. They're doing test-driven development. They're writing unit tests. They're writing integration tests. Maybe they're even writing end-to-end tests. They are doing exploratory testing as they go. They are really thinking about the edge cases and what really matters to the user. They are doing all of the right things. They are building in quality. And then something interesting happens. They come across a particular test case, and they realize that this is going to be a massive pain to test. It's going to be really, really difficult to get this tested. And then they look over here and they see, well, there's a QA column, isn't there? We know we should test it here. We know we should really build in that quality. But there's a QA column, so let's just push it over there. And just like your desk becomes a flat surface that affords having mess put on it, the QA column becomes a flat surface that affords having quality pushed onto it. We all know we should build in quality, but it's so easy just to push it later. There's a QA column. They can do it over there, right? And then the developer pair has another question. They ask themselves, well, should we go and work on this task? Should we go and join and pair with a QA, bring our perspective, combine our perspectives together to come up with the best, to really do this the best way we can, to share that knowledge, to reduce those handover costs? Or should we just pick up a new story? And they know what they should do, right? They know that pairing and collaboration and bringing together different perspectives is incredibly valuable. But you know what? This QA column is called QA, and there's a QA over here, and this development column is called development, and well, we're devs, right? So this is kind of our land, and that's kind of their land, and yeah, let's just assign the QA, right? What's interesting here is every single person in this story knows what they should do. They know the right thing to do. They know what's going to lead to the best outcomes. But the system around them, the affordances of the system around them, make it really easy to do the wrong thing. It makes it really easy to push quality to it just a little bit later. It makes it really easy to, separate devs and QAs because we've got our columns, right? Everyone knows the right thing to do, but the system around them makes it hard. Just like in real life, the problem is not the people, it's the borders we put between them. This border, this line on a board creates a dichotomy, creates affordances for pushing quality later. So just like in real life, let's get rid of the borders. Let's stop blaming people and let's get rid of the borders. This board sends a very different message. When I see this board, it says quality needs to happen here. Testing needs to happen here because there is no space that we can push it later. This says to me that QAs, devs, testers all need to work together. They don't have their separate realms. They aren't separated in time and space. They need to collaborate. They need to be working together at every step. They need to be building in quality. Even if we understand that it's the right thing to do, if the system makes it easy to do the wrong thing, very often we're going to do the wrong thing. So get rid of the QA column. It creates an affordance for building in quality if you get rid of that QA column, because it sends a clear message, a signal to the team that this is the only place quality happens, in this development column. Let's get rid of that QA column. Change the way we think about our work, change the way we look at our work. So the next affordance I want to talk about, I kind of came across when I was talking with Daniel Terholsnorth, all-around lovely person, former thought worker. And we were chatting at a conference in Ireland a couple of years ago. And he said something, just kind of in a conversation with a couple of people, he just threw out one sentence that I found really interesting. He said, a testable system is a well-designed system. And I found this fascinating. Because testability is obviously something that we talk about, but a lot of people struggle with this concept. What does it really mean to make something testable? And a well-designed system, that no one agrees on. The easiest way to start a fight in the software in the software community is to point at a piece of code or to point at a system and say, this is well designed. You will immediately have 100 people with 200 different opinions fighting you. And he just said, these two things that are very difficult to define are the same. They are isomorphic. A testable system is a well-designed system. I've been thinking about this for years, and it's really been burrowed in my head. And I agree with him. I think about the details here. I would say that a testable system is going to be modular. You're going to be able to break this system up into small components, replace them easily. This is what allows us to do mocking, for example. If I have a database that my application, that my system relies on, I don't want to need to start up that entire database every time I run a test, especially if it's a small self-contained little unit test or possibly an integration test. You know, these smaller, faster, lower level tests, I don't want to have to spin up all of the dependencies. But if they're modular, they're clearly decoupled, I can take one bit out and I can replace it with a mock or a fake or a stub to simplify my tests. We all know the test pyramid, right? We want as many unit tests as possible. We want to get as much fast feedback as we can. That's enabled by this modularity. That's what allows us to write these really fast tests. And I'm also going to argue that a well-designed system is modular. A well-designed system, I should be able to take components out and replace them easily. And this is fractal. I should be able to take out a single function easily. I should be able to take out a library easily. A module or a service or an entire microservice. I should be able to take these systems out and replace them easily. This is something that enables evolution of my design. I'm not going to get the design right first time, so it's more important that I make it modular and evolvable going forward. Clear, well-understood interfaces. All of these things make a system well-designed and testable. I'm going to argue that a testable system should be observable. The technical definition for observability is how well we can understand the internal workings of a system based on its based on the signals we get from it on the outside. Have you ever written a test or run a test where you triggers some process, and it's got to go through 5 or 6 different systems, and it triggers a third party somewhere, and it sends an email. So you press a button, and then you need to wait 20 minutes for all of these things to happen. And finally, the only way you actually know whether or not your test succeeded is that you got an email at the end, right? Maybe you create an account, and the only signal you get that it actually worked is an email. You ever had that experience? Maybe your system wasn't as observable as it could be. Maybe you weren't able to actually look inside this system and understand what's really going on. Being able to understand the internals of the system clearly and easily is something that enhances our ability to work with it, to debug it, to test it. And I'm also going to argue that a well-designed system should be observable. This is critical for operational reasons. If something is going wrong in production, you should be able to understand what is going wrong. Not just the system is down, the server is down, but why? What's really going on inside? What's causing that? It's one thing to have a graph of response times. It's another thing to be able to really dig in and understand what's going on and investigate. This is a really critical operational concern for most systems. And finally, I'm going to argue that a testable system is simple. We've all tested, I assume, or I hope not really, but I've tested methods with 40 arguments before now, which was a depressing experience, to be honest. Because I've got to look through all of these arguments and understand, okay, which of these are optional, which of these are mandatory, which of these have defaults that I can leave, what really matters to my test. And then once I've narrowed it down to the ones that actually matter, I need to think about the combinatorial complexity and how many sort of branching logic flows this is going to create. That's a huge pain. But if my system is simple, if the interfaces are simple and clearly understandable, if I understand this is what this interface should do and here is how it works very quickly and easily, that makes it easier to test. That makes it faster to test. That gives me more confidence in my tests. Got asked once recently, who tests the tests? That's only a concern if your system is overly complex. If your tests are overly complex as a result. So a testable system is simple, and so is a well-designed system. A well-designed system, every component you look at should be able to fit in your head. This is also a rule of thumb from Dan North and James Lewis, I think. A microservice should be simple enough to fit in your head. A library should be simple enough to fit in your head. A function should be simple enough to fit in your head. You should be able to understand them. That understandability is key, again, to evolving your system. You might have written some beautiful, perfect code, but if the next generation of developers can't understand it, they aren't going to be able to work with your system, and it's going to slow that pace of change down to a crawl. I think back to that example from earlier, right? The developers who know that they should test something, but they're complaining about a particular test case or some tests they need to write. And they're saying things like, this test is going to take a long time to write. Or this test is going to be really difficult to set up the test data for this. We need to set up all these flags and all these things because it's really complicated. Or this test is going to take a long time to run. It's got to go through all these various systems before we actually get the result. Or the classic, this test is going to be really flaky. Maybe you've heard all of these things. If you're very unlucky, you've heard all of these things from the same person in the same sentence. But when I hear these things, I get frustrated. Because there's no reason that these need to be true. These aren't immutable facts of software design. Not every system has to be like this. What I hear when I hear people saying this is, this system is not testable. I hear this system lacks affordances for testing. That's why I think we need to make testability a first-class concern in our system design. We need to think not just about performance and the cleanliness of the code and how beautiful everything looks, but how well does it afford testing? How testable is this system? Because that's something that is going to enable evolution going forward. That's something that's going to enable us building in quality. I think back to that board from earlier. We've got where we got development, where we got dev and QA separated. I had a team recently ask me, they had a board just like this. They had developers doing the development, doing the product code, and they had QAs doing the test code. You know, classic, lovely waterfall style. And they said, how do you estimate testing tasks? Because what they had is they had a development task, and then they had a testing task as well to write all the tests. And I said, I don't. I consider them the same task. That's why I get rid of those. That's why I like to get rid of the QA column. If we treat these things as separate, we ignore the fact that they impact each other. If developers are just responsible for writing the product code and handing it over to testers, they have no reason to invest in testability. Why would they do that? Testing is someone else's job. But if we understand that testing and building in quality is everyone's job, it's a shared responsibility, well, now we understand that we actually have levers we can pull here. There are things that we can change that is going to make our job easier. That's going to make it easier to build in quality, make it easier to test. And that's why I consider focusing on testability, designing for testability, making a first-class design concern creates an affordance for quality. So that's two affordances so far. And the last affordance I want to look at today, I want to start off with a quick story. It's a story of the very first release I was ever involved in my career. I was working for a very large company. You've definitely heard of it. You can figure it out if you find me on LinkedIn. It's not that hard to find. But I was working for a very large company, largely doing business to business software. And one day, the sort of manager, our lead manager of our whole department, walked into the room. We had a big floor. We had about I think it was about a dozen teams or so, maybe 100 people in total, probably more in total. And our manager walked out, and full disclosure, he wasn't wearing a crown. I just had to put that there to sort of distinguish him from the others. And he called everyone out onto the floor, right? He said, okay, everyone, all the teams, get up here, get up here. So everyone came out. All the teams gathered around him. And he made an announcement. He said, our competitor has just announced a new release. They have announced that they are going to release something new, something exciting, something that's going to be directly in competition with us. And he said, can we release before them? I want to get our product live before they do to beat them to the market. So we get that first mover advantage. Can we do that? And all the teams kind of looked at each other, and the tech leads in particular sort of looked at each other very nervously. And one of the brave ones kind of put his hand up and said, no, you can't actually. No, it's not possible to release right now. And the manager was a bit confused by this. He said, but hang on. I've just seen you showcase your features. Last week, your team showcased a fancy new feature, something that's super cool and super interesting. And you're telling me we can't release that? I've just seen it working. What's going on? And the tech leads, the teams had to explain that they were actually working on branches. They were working on long-lived feature branches. Each team was developing on their branch, doing all their testing on their branch, doing their showcases on the branch. So when that new feature was showcased, it was showcased on a separate branch, separate from everything else. And he said, well, okay. So what needs to happen? They're saying, well, first, before we can release, we need to bring these branches together. We need to merge these branches. So there's a big integration phase. And this is a bit of a pain in this particular context because these feature branches had been going on for several months. And the integration, bringing all of these code changes together in one place from a dozen or so teams, took weeks. It took a long time to do this. Merge hell. People spent, multiple days shouting at each other in room about, oh no, this line of code is the one that needs to win. A ridiculous process. But at the end of that, once we had brought all of these code changes, all of the most up-to-date features together, then we could start systems testing, right? It only really makes sense to test the system as a whole once you have the system as a whole, fairly obviously, right? And then after that, we can do our installation testing. We had to make sure that we could install our software on various the various platforms that we supported. And then we do the other testing, load testing, pen testing, migration testing, all of these things. Don't forget performance testing. That was a big one. License updates as well. Like license updates isn't even a testing task, but it's something that needs to be done, right? It's an incredibly simple and boring task where you go into a license file and you update the year. Just a little manual step that we had to do, right? It's not that hard, but all of this stuff adds up. And all of this stuff, there's an opportunity, there's a chance for something to go wrong. Someone updates the license file in the wrong way, or the load testing fails, or the penetration testing takes longer than we expected, or the installation testing throws up an error and we need to go back and change something. It's not that each one of these tasks is extremely hard, but when you add them all up together, it adds up to a lot of time, and there's a lot of opportunities for things to go wrong. But after we've done all of this, then and only then can we release. This whole process took about 2 months, a little bit over 2 months. And we actually, at this particular company, we actually organized our summer barbecue around these release processes. So we knew that if we started our release process in May, then by, we'll go through May, June, and then start of July, maybe mid-July, we'd have our company barbecue, we'd have our like team or our department barbecue. And this was really important because this was a horrible and stressful process. Everyone was, got to get this release, got to go through all these things. Everyone got really stressed whenever something went wrong because they knew that pushed out the release date. We borrowed people from other departments to do some manual testing. It was a whole thing. And I compare this to the most recent release that I was involved in, or one of the more recent releases that I was involved in. So a couple of years ago, not the most recent, but one sticks in my head in particular. It's a couple of years ago when I was working at ThoughtWorks, and we were working with the clients. We were at the client office. That was back in the before times. And our PO, our product owner, walked into the room and they said, hey, so can we release? And we went, yeah, sure. One of the developers went into a config file. We found the feature flag for the new feature. We changed it from off to on. Git commit. It automatically triggered our build pipeline. Went through our build pipeline in, I think it was about 20 minutes at that point. We got it down to 15, but I think at that point it was about 20 minutes. All automatic. And then it was live. No one in the team noticed. The rest of the team kept on working. They kept on developing. That release was boring. And releases should be boring. But more importantly, that release was a business decision. The PO wanted to release, and they could. In that previous story, the manager wanted to release, and they couldn't. Releasing was a technical decision, not a business decision. The change here is that more recent team was doing continuous delivery. We were a continuous delivery team. Actually, we're a little bit further. We were doing full continuous deployment, but that's another story. Continuous delivery is the ability to get changes into production or into the hands of our users safely and quickly in a sustainable way. It means the ability to get every line of code we write live in production in front of our users quickly and safely. And there's a lot of stuff that goes into this. There's a lot of discipline that's needed. If you're going to do continuous delivery, you need a repeatable, reliable release process. That release process I described, that long manual release process, was not repeatable. If you had different people in the room, different things would happen. One person might run a performance test in one way, another person might run a performance test in another way. Some people will deal with merges in different ways. That's not repeatable. We should be able to press a button and guarantee that something is going to be released in a particular way. And if I press that same button again, I guarantee the exact same thing is going to be deployed. Repeatable and reliable, which means we need to automate almost everything. Not everything. This isn't about getting rid of people, getting rid of human intervention, but understanding that there are things people are good at and there are things that machines are good at. So let's use people for the things that people are good at and machines for the things that machines are good at. Machines are great at boring, repetitive tasks, updating a license file, running translation checks, doing all of these steps, doing all of these individual steps of a release process. Machines are great at. So get them to do that. Don't make that manual. We also need continuous integration, which means we're not working on long-lived feature branches. All commits, I mean, not all commits, but we need to be regularly committing to our mainline branch, the trunk. No long-lived feature branches. I love Jez Humble's continuous integration certification. It's 3 questions. It says, do you commit to your mainline branch at least daily? Does every commit trigger an automated test and build? And if the build breaks, does it get fixed in 10 minutes? The answer is yes to those 3 questions. Congratulations, you're doing continuous integration. Love that. It's very, very short and simple rule of thumb. But you need that if we're doing continuous delivery. We also need to bring the pain forward. If something's difficult, if something's painful, do it more often. You will get better at it. If something's really difficult, do it more often so you have a pressure to automate it. So you have a pressure to get better at it and make it more reliable and less painful. It also means that the team takes responsibility for delivery. The team's responsibility isn't writing code or completing a feature. Their responsibility is delivering software to their users. They take ownership not just of the code, but also of the pipelines and their release and deployment process. What that means is done means released. I've seen teams and organizations with a done column and a big list of stories in their done column, all of these features, but they're actually sitting on a feature branch somewhere and they're months away from being released. And there's still a bunch of systems testing they need to do before they can be released. I keep looking at that. I'm like, mate, that's not done. There's still work to do there. Done needs to mean released. And continuous delivery also means we need to build quality in. If every commit we write could be getting in front of our users, it might be hidden by a feature toggle. It could be hidden. It could be turned off. But if every commit, every line of code we write could end up in front of our users, we need to build quality in. It is impossible to push quality to later if it is going directly to our users. So we need to build quality in. It is impossible to do continuous delivery without building quality in. Continuous delivery creates an affordance for quality. It makes it very hard to do the wrong thing. It forces the team to take a bit of discipline and do the right thing to build in quality. I think a lot about a quote from the lovely Mary Poppendick, lean software and sort of lean manufacturing expert. A couple of years ago, I can't remember where she said this, but she said, the only way to go safely is to go fast. I found that, again, that was another another thought that kind of buried its way into my head there. I found this really, really fascinating. The only way to go safely is to go fast, right? Think about this, right? We've got 4 options. Let's put this on a table, right? We all love a good 4x4 matrix. So you've got 2 options, right? Slow and fast, how often you release, and then safe and unsafe, by which I mean, like, how much do you care about quality? How much do you test? How much do you want this release to be reliable and good quality? You've got 4 options here. So one option is you go slow and unsafe, right? So you release once a year and you don't care about testing. You just push whatever you want to production, but you only do it like once, maybe twice a year. This is obviously a terrible idea. I don't know anyone who does this. I think they've all gone out of business. Very bad idea. Don't do this. And then you've got this option up here, right? You go fast, but unsafe, right? So you're pushing code to production every day. Every line of production gets right in front of your users. And you don't really care about testing. You don't really invest a lot of time in testing. You just kind of, just throw it out there. And the interesting thing is, this can actually work for a little bit. If you're building a proof of concept, this might actually be fine. If you're a very early stage startup and you really, really, really just need to optimize for learning, this might be okay. Just kind of skipping on quality for a little bit, because this code isn't going to live very long anyway. It's basically just a prototype. This might be okay for a bit, but very, very quickly you're going to run into a wall. If this code lives for more than a few weeks, it's going to become a huge pain to work with. So this can work for a tiny bit, but it is not sustainable. And this is why a lot of companies opt for slow and safe, right? Slow and steady wins the race, slow and safe. I've had, this was what my first company did. My first, what happened in the first release. They only released once, sometimes twice a year. So very slow, but they took safety very seriously. They had literally a 2-month release process with weeks and weeks and weeks of testing. Slow, but safe. And this makes a degree of sense. But I would argue that this safety is an illusion. You're not actually as safe as you think you are here. See, if you only release once a year, you are not going to be very good at releasing. Remember that principle, bring the pain forward. If something is difficult, do it more often. If you don't do things very often, you're not going to be very good at them. Think about the things you do every week. You go to the shops, I assume. I go to the shop down the road from me, get my groceries, go in, bread, eggs, milk. I could do that with my eyes closed because I've done it so many times. I'm practiced at it. There's a whole bunch of things I need to do. I need to understand how the store works. I need to move my arms. All of those are surprisingly complicated activities, but I do it every day or every week, so I've got a lot of practice. It's easy. And then I think about the things that I do once a year. I do my taxes once a year. The taxes aren't intrinsically too difficult, but because I do them only once a year, I'm not very practiced at them, and they cause me a lot of stress. It's just some paperwork, but I don't have very much practice at them. If you go slowly, you don't build up that practice. The only really sustainable option here is to go fast and safe, is to invest in safety, in making it fast and sustainable, automating, doing all of these continuous delivery practices. That is the only sustainable approach here. The only way to go fast is to go safely, and the only way to go safely is to go fast. I'm a QA, and sometimes when I join a team, I announce, hey, I'm Steve, I'm a QA. I sometimes see people kind of rolling their eyes, like, oh, it's a QA. He's going to start shouting about safety. He's going to tell us to slow down and write more tests. But I actually don't do that. The first question I ask most teams I join is, how often do you release? When was the last time you pushed to production? And how can we make that faster? Because the only way to go fast is to go safely. That's why I think continuous delivery creates an affordance for quality. it forces us to do the right things to maintain this sustainable delivery pace. So I've got these three, so I shared these three affordances: removing the QA column, designing for testability, and continuous delivery. Obviously, there are others. These are just a few that I picked up. But I think these are important because when I think about the arc of my career, I started as a tester. I started as someone, my very first team, the devs wrote the code, and I wrote the tests. The devs handed the code to me, and I was the Roman emperor going, yes, it goes to production, or no, it doesn't go to our users. And that felt cool, right? I was the gatekeeper. I was the decider. That was fun, but it was an adversarial relationship. If I found bugs, I win. If I didn't find bugs, the devs win. I was standing on the outside of the process, shouting in, telling people to do better at quality. And that isn't what I do anymore. Now I see my role as helping teams take ownership of quality. Helping teams build in quality. It's one thing to say that we build in quality or say that we should build in quality. It's another thing to make that easy, to really build the skills, the techniques, the structures around us that make it easy to build in quality. I see my job now as helping teams take ownership of quality. I see my job now as building affordances for quality. Thanks. That's the end.
Thank you, Steve. That was, like I would say, a really keynote. There were some thought-provoking ideas. It was also clear from the chat during your presentation that people had some issues, for example, with the removal of the QA column. Definitely were some issues there.
Love it. Love the stuff.
I'm going to invite the participants to post any questions they have in the Q&A section that we can go over them. I already picked one from the chat. If the solution is always buggy, why does it matter if it is released more or less often?
It doesn't. If the solution is buggy, you should probably fix the bugs. Yes. So the point about releasing more often is it forces us to engage with how do we make this release process more sustainable? How do we make this more faster, more sustainable, more reliable? If it's just buggy, again, probably address that first. Yeah. But this is rather about thinking about the systems around it and what we're going to optimize for. If we are doing continuous delivery, then we are going to optimize for making that release process reliable and fast, which are very different things. So yes, one does not magically make quality happen. It doesn't make the bugs go away. You still need to care about that, but it forces you to care about it in a new way. And that's the affordance part of it there.
Okay, questions are coming in the Q&A. Do you think removing the QA column could result in developers forgetting to include the QA?
It could, yes, absolutely. Which is why I strongly advocate for having QAs and developers being part of the same team. I generally, whenever I join an organization as a tech consultant, as mentioned, I try and argue for not having a separate QA team and a separate development team, because again, even if you take away the column, but they're in separate teams. It's very easy to forget them, right? That again creates an affordance for separating QAs and devs. So yes, it could lead to it, which is why they should be in the same team, why they should be working together. This is something which could be misused, I guess, or go the wrong way. And these are changes that need to be managed, that need to be guided, so they don't go in the wrong way. It could, but in my experience, it has a huge positive effect. Now, a friend of mine, Lina Zobita, recently did a podcast with another friend of mine, Finn Lorbeer, I've also been on the same podcast. But just last week, she released a podcast on removing the QA column. I haven't listened to it yet, but they are both very smart people, so I'd recommend you read it. It's called Quality Bits. I think it's qualitybits.tech. I'll find the link and I'll post it in the chat somewhere. But yeah.
Okay, great. Another question: how to convince dev to work with QA within one column?
How do we convince devs to work with QAs? So I'm a huge fan of having different perspectives coming together on a problem. I've been a developer in the past. I studied computer science. I can write code, and I can happily sort of sit next to devs and work with them. But even if you don't, maybe some of you, for example, have an ISTQB certification, right? Looking at things like, you know, how do we test, and what are the sort of approaches like boundary value analysis and all of this lovely stuff. That means you bring a perspective that some people might not have. They might not think about, oh, this is an edge case that I should care about, right? That different perspective is really valuable. And I found it's really enlightening when we pull these different people together. I sat with a dev once and asked them a bunch of questions, and it seemed really annoying at the time. But at the end of the session, they said, wow, I have never thought about these things before. This was really helpful. Just do it and work together. You're all working on the same thing. Bring your perspectives together, and people, in my experience, pretty quickly see the benefits.
Yeah. Thanks, Steve. Questions keep on popping up.
There's a lot of questions I can see. Yeah, wow.
I don't think we have enough time for all of them, so I'll just continue with the next one. Where is a good place to start to automate everything in support of continuous delivery, making sure this is fast and safe? How do you know if you're using the right tools for the job?
I would say don't automate everything, automate almost everything, automate the things that make sense. Yeah. And I would start with so think about that other principle, bring the pain forward. What is the most painful, difficult part of your release process? Automate that, right? Or for that matter, also just go for some of the easiest stuff, right? If you need to type, you know, javac compile with a bunch of arguments, but if you mistype one of the arguments, something goes wrong, or, you know, make or build or something, put that in a script, tie that up to a CI pipeline. So every time you commit, it runs that, and cool, you now have a repeatable artifact. That's something you can build on. And then find the things, where are the opportunities for things to go wrong in your release process? Maybe go there. Find the things that are easy, and find the things that are really difficult. Those are probably two good places to start, ironically.
Okay. Another one, can all this work in a waterfall methodology?
Waterfall, my favorite term. So yes, but you're not really going to see any value from it, which is the interesting thing. So Daniel Turhouse has this wonderful phrase, water scrum fall, where you have a big project plan, multiple years, you know, design planning, but you do scrum in the middle. So you have a bunch of iterations and everyone says they're agile, and we feel lovely, but then it only gets released at the end. The whole point of agile, the whole point of this is, like, go and read the Agile Manifesto, one of my favorite manifestos. The whole point is we want to satisfy our users with the early and continuous delivery of valuable software. Now, if you do all of these things, you do continuous delivery, you invest in all these things, yes, you're going to get some benefits, like, you know, a reliable release process. But if you only actually release at the end of a 6-month project, a big long waterfall project, well, that's not really the early and continuous delivery of valuable software, is it? So yeah, please do try to avoid water scrum fall. There are definitely benefits to the team, but they're going to be focused on the team. It's going to make your life a little bit easier, but it's not really going to deliver any business benefits, which in turn is going to make it very hard to justify to the wider organization. So yeah.
Okay, thanks, Steve. We're running out of time, so I don't know if you're available in the chat or somewhere to answer all the other questions. But we have to close this session, and I would like to invite everyone for the next session by Marcel Veselka, who will be talking about autonomous testing, so using AI to do test automation, which seems very interesting to me. I don't know about you, Steve, but I think it can also help in whatever you just explained. So thanks, everyone. Thanks, Steve, for his wonderful presentation, and hope to see you soon in 5 minutes for the presentation of Marcel.
Fantastic. I'll try and hop into the chat and answer some questions, but busy day. I'll see you folks in a bit.